Well, I thought I'd go through a few examples for you to try and explain some of the proofs that I've asked you to do in exercise 3.A. Now the thing is, you need to make some sort of statement. So if n is a number, then 2n, or an integer, then 2n will always be even, because 2 times any number will always be even. That means, therefore, that 2n plus 1 will always be odd, as will 2n plus 3, etc. 3n will be a multiple of 3. I know we've touched on this before actually, so hopefully this is just a recap for you. So you need to remember these little things here to help you when it comes to the proofs. So if we want to prove that the sum of two consecutive odd numbers is an even number, so let's start with that. So two consecutive odd numbers, well, 2n plus 1 is an odd number. Sorry, that's 2n plus 1. That's my first odd number. That means that the next odd number is going to be 2n plus 3. It's the next odd number along. You're adding 2 each time to get the next number. So if we simplify that, we collect our like terms. We have 2n plus 2n will give 4n, and 1 plus 3 is 4. I can take out a fact. We want to prove that it's an even number. So I'll take out a factor of 4, and n plus 1. And we've just said an even number is 2 times something. So we could, if we like, write that as 2 times 2n plus 1, which sort of just goes to prove that the sum of two consecutive odd numbers is an even number, because when you multiply anything by 2, it will be even. So that would be an example of a proof. You have to make these initial statements and then simplify your answer to get it into some sort of standard form as here to prove the fact. Okay, so if I jump over to the next slide. On this slide here, we've said we're being told that for every integer value of n, so for every n squared plus n plus 41 is prime. So that's what we want to try and prove. We want to prove that n squared plus n plus 41 is prime. Okay, so this one is slightly more difficult to prove. We basically it's a little bit of trial and error. So we say, okay, what happens when n equals 1? Well, n squared plus n plus 41 will give me 43. And it is a prime number, so tick. Let's try n equals 2. Well, if n equals 2, that will give us 2 squared plus 2 plus 41, which is 47. And again, that 2 is prime. So we can tick that off. When n equals 3, we have 3 squared plus 3 plus 41, which is equal to 53. And that again is prime. So let's try n equals 41. So this is where we're going to try our proof. So 41 will appear in each term. So let's try n equals 41. So that will give us 41 squared plus 41 plus 41, which equals 1763. Now I could take this here and this expression here and I could factorise it. They've all got 41 in them. So that will become take out a factor of 41. That will give me 41 plus 1 plus 1. And that will be 41 plus 1 is 42, plus 1 is 43. That's like saying 41 times 43. Now 41 times 43 isn't prime, is it? Because we know that when we work that out, we'll get 1,763. 1,763. Now 1,763 is divisible by 43, and it's divisible by 41. So the statement is false. This is not prime. So it's not prime as it doesn't work for n equals 40. So it does not work for n equals 41. It doesn't actually work for n equals 40 either. There you go. That's a slightly more complicated proof. And again, you'll get better at this with practice. So I'm looking here at question 7b on page 115. If you multiply two consecutive integers and subtract the smaller number, you always get a square number. So let's have a look at this one. Let's just follow it through. So two consecutive integers. I could have n. My next number along would be n plus 1. If you subtract the smaller number, you always get a square number. So if you multiply them together, don't know why I put that in brackets, so let's go back. So if you multiply them together, that will give us n squared plus n. If you multiply two consecutive integers and subtract the smaller number, you always get a square number. So that means, okay, n squared so that will give me, so I've got my n squared plus n. I now have to subtract my smaller number minus n. I'll get n squared. Voila. Let's try a different one. So let's have a look. My two consecutive numbers, I could have n plus 1. The next number along would be n plus 2. Using FOIL, that will give me n squared plus 1n plus 2n is 3n. And 1 times 1 is 2. And then it said to subtract the smaller number, so my smaller number is going to be n plus 1, so I'll have n squared plus 3n plus 2 minus n plus 1. Oh, look, here we've got to watch our sign. So we'll have n squared plus 3n plus 2 minus n minus 1. And that will give me n squared plus 2n plus 1. And if I was to factorise that, I will have n plus 1 times n plus 1, which we can write as n plus 1 all squared. So again, we have a square number. You need to remember a bit of your factorising, etc. But you could use this one as your proof and you don't need to worry about factorising quadratics. This one you should be able to do after our next lesson. So I hope that explains how to do some of these proofs. We have done some before, but I will be telling you on Insight which questions I would like you to do. Now the last bit of chapter 6, we're going to be looking at expanding double brackets and simplifying. I'm just going to go through a couple of examples to refresh your memory. The thing you've got to remember here is some of you liked to remember FOIL. So first, outers, inners, last. But the thing is you've got to remember to check are your signs. Okay, So let's take our first example. We'll have a look at, we've been asked to expand and simplify 2x plus 5 multiplied by x plus 2. So using our little mnemonic, we have first, FOIL first. So I'm going to multiply the two first things there. So 2x times x will give me 2x squared. We then want we want to multiply the two outer terms together. So 2 times 2x will give me 4x, because 4 times 2 is 2. I for inner terms, plus 5x. And then lastly, 5 times 2, the two last terms, multiply. We're always multiplying. 5 times 2 is 10. And simplifying that will give me 2x squared. 4x plus 5x is 9x plus 10. And we have expanded our bracket. I'm going to go through a second example here. So underneath, second example, we've been asked to expand and simplify 4b minus 3 and 2b plus 7. Okay, so I'm going to multiply my two first terms. 2 4s are 8 and b times b is b squared. My two outer terms, 4 times 7 is 28. I've got a b. Now here I've got minus 3 times 2, so that's going to give me minus 6b. And then minus 3 times 7 is minus 21. So write everything out and think about your signs, and then simplifying at the end, 8b squared plus 28b minus 6b is plus 22b, and then we have minus 21 at the end. So expanding double brackets, think about your signs. I'm now going to go over a third example. You could be asked to expand and simplify 2x minus 5 and 3x minus 1. So multiplying our two first terms, 2 3s are 6, and I've got x squared. 2 times minus 1 is minus 2, and I've got an x. Minus 5 and 3, minus 15x. And minus 5 times minus 1 is plus 5. Watch out, and you're multiplying. Look out for your signs. And simplify. So 6x squared minus 2 minus 15 is minus 17x plus 25. Sorry, plus 5. Question 4. Now, this is where a lot of you went wrong in the last homework. So if you've got 3x minus 1 and you've been asked to expand and simplify, when you square something, you're squaring the whole expression. So that means 3x minus 1 multiplied by 3x minus 1. Multiplying the two first terms, that will give me 9x squared. Outer terms, minus 3x. Inner terms, minus 3x. And minus 1 times minus 1 is plus 1. Simplifying, minus 3x minus 3x is minus 6x plus 1. Watch out for your signs. Write everything out and make sure you are working through things methodically. So you can pause the slide and maybe do the questions that I've set from 6.4s up to the end of questions 6 or 7. Or you can carry on. Now when we factorise an expression, we want to put it back into brackets. Now you've got to decide when you put an expression into just a single bracket or two brackets. Now we've got a quadratic here. We have x squared plus 5x. Now that is a quadratic, it's got a square in it, the highest power of x is 2, but it's only got two terms, so two terms in x. So I know here that I'm going to have to just have one bracket and put out the highest common factor. So in this case, the highest common, both terms have got an x, and the lowest power x goes on the outside. So x times x will give me x squared, and to get the 5x, the x is already outside the bracket, so I'll have 5 on the inside. I could equally have something like 24x squared minus 32x. So I look at this, and the highest common factor, I've got a quadratic because I've got power of 2 there, x squared, but I've only got two terms, in both with an x in. I am subtracting, but it's not different to 2 squared, so I don't need to worry about that. Okay, so the highest common factor here is going to be 8. Then I look at my x, both terms have got an x, so I can put an x on the outside as well. So 8 times 3 will give me the 24, and I've got an x outside the bracket, so to make it x squared I need another x on the inside, minus 8 times 4, I need 32, so 8 times 4 will give me the 32, so I've got a 4 there. I need an x, but the x is already outside the bracket, so my factorised expression will be 8x bracket 3x squared minus 4. However, when you've got an expression, we've got x squared plus 5x plus 6. I've got a quadratic here, but I've got three terms. I've got an x squared, an x, and a constant. So I can't just do one bracket. I've got to try and see if I can factorise by putting it into two brackets. Now, if you remember when we've done this before, what we're looking for are two numbers which multiply to make 6 and which add together to make 5. Now you've got to think about the sign, so we can make a little column and look at all the combinations of getting 6. So I can have 1 and 6. I could actually have minus 1 and minus 6. That will give me plus 6. I could have 2 and 3, and minus 2 and minus 3. And you go through your pairs to see which ones will add up to 5. And you'll find that it is 2 and 3. Now the more confident you get, the less likely you are to have to write everything out. You just learn to see them. So putting that into two brackets, I will have x at the beginning of each one, because x times x will give me x squared. And one bracket will have plus 2, and the other bracket will have plus 3. And it'll do as well just to check quickly it works. So two first terms, x squares, then I'll have 3x plus 2x will give me the 5x. Multiply the two last terms, 2 times 3 will give the 6. Tick, it works. You may wish to pause the slide now and have a go at factorising this on your own. So if we want to factorise this, we've got three terms, a squared, a, and a number. And we're going to see if we can put it into two brackets. So we want two numbers with a product of minus 24 and with a sum of minus 5. So we'll make a list. So that means when we're multiplying, you've got a negative, one of the numbers has to be positive. So I could have 1 and minus 24, minus 1 and 24. I could have 2 and 12, minus 12, or minus 2 and 12. I could have 3 and minus 8, or minus 8 and 3. And as you're working through, you'll probably come across one that works. So if I look at 3 times minus 8, it gives me minus 24. And if I add those two together, I get minus 5. So that is, they are the numbers that are going to go into brackets. So both brackets will have an a at the beginning. And then I'll put plus 3 in one bracket, minus 8 in the other. And I'll just try it out. A squared, 3a minus 8a is 5a. And 3 times minus 8 is 24. It works. And let's write another one. We could have factorize x squared minus 19x minus 20. And again, stop the slide, stop the PowerPoint if you want to have a go at factorising this yourself. So we want two numbers with a product of minus 20 and a sum of minus 19. So one of them's got to be negative. So I could have minus 1 and 20. But if I add those together, I'll get 19. So I could have 1 and minus 20, and that will give me minus 19. So that pair of numbers works. So I'll have x at the beginning of each bracket, plus 1 and minus 20 in each other. And it doesn't matter which way round they go. And again, check your answer and make sure it works. Now with this example, there's a little method that we can use to try and help us. So it's remembering that the general form of a quadratic is actually, the general equation of a quadratic is actually ax squared plus bx plus c. So in this little method, we need to work out what AC is. So AC in this case here, in this example, that's my A. So here my A equals 2, B equals 5 in front of the x, and the number on its own is 3, so my C equals 3. So AC is 6 and B equals 5. So what I want to do with this method is I want to look for two numbers with a product of 6 and with a sum of 5. So I say, okay, I could have 2 times 3. Oh, that one works. 2 3s are 6 and 2 plus 3 is 5. So if I take my original, sorry, it's in terms of y, isn't it? So if I take the original question, so I've got 2y squared, and then I had plus 5y, so I'll do it in a different colour, plus 3. Instead of the 5y, I'm now going to put these numbers here. I'm going to put my 2 and 3. So that will give me 2y squared, plus 5y becomes plus 2y, plus 3y, and then I have plus 3. They're exactly the same thing. I've just expanded the y term with the numbers that I found for A, C and B. Okay, so taking that, what I'm now going to do is factorise the first pair of numbers. So I'm going to factorise that. Now factorising that will give me 2y and then y plus 1. Okay. I'm then going to take the second pair of numbers and factorise those. So they've both got a 3 in them. The highest common factor is 3. So that gives me y plus 1. And what you should notice at this point is that both these brackets here should be the same. So now we come to the final step. The final step is I take both of these numbers here outside the bracket. I'll take both of those and they're going to go inside the first bracket, so 2y plus 3. And the brackets here are the same, become your second bracket, so y plus 1. And we factorise. Now this little method will work for any quadratic you get. Now some of you might have been able to do that by inspection. Okay, so 2y squared plus 5y plus 3. You might have been able to do that by just playing around with the question. So I will show that here. So if you've got 2y squared plus 5y plus 3, you know to get y, you multiply the first two terms together. So you know that that's got to be y and 2y. The last terms are 3 and 1. Now if I tried this out, I would multiply the two last terms, 2y plus 3y, which is 5y. However, you might have you might have put those in a different way around. So you could have written 3 and 1. So it's just a case of trying it out. You'd have said 6y plus 7. That'll give me 7y, not 5y. I've done it wrong. Therefore, it must be the other way around. So the point I'm just trying to make here is using inspection, this method here, it's a bit of trial and error. But that's fine. Some of you are quick at that. Or you can use this method here. So I'm not going to go over the inspection method again. I think you should be able to practice that. But what I will do on the next slide is go over this method so that you can play through it again should you need to. So on the next slide, we've been asked to factorize. You've been asked to factorize. Let's have 2x squared plus 4x minus 6. So here my A is 2, B is 4, and C this time is minus 6. So we need to work out what AC is. So AC is going to be 2 times minus 6, which equals minus 12. And B equals 4. So what we're looking for are two numbers with a product of minus 12 and with a sum of 4. So I'll make up my little list here. So I can have 2 times minus 6 will give me minus 12, but 2 take away 6 is minus 4. So swapping those around, I'll have 2 and 6, and that should work. So that becomes the pair of numbers that I'm going to put into the expression. So 2x squared plus 4x minus 6 I can write as 2x squared minus 2x plus 6x, so getting that from here, minus 6. What we then go on to do is factorise the first pair of numbers, first terms. So I'm going to take out a factor of 2x. That will give me x on the inside and minus 1 inside the bracket. Plus, I'm now going to factorise the second pair of numbers. So the highest common factor there is 6. And inside the bracket I should have minus 1. So now I can see I must have done it right. Those two brackets are the same. The two numbers outside each bracket will go inside the first bracket of our factorised expression. So 2x plus 6. That's taken from there and there. And then the next bracket is just whatever is inside the two brackets that are the same, so x minus 1. And there you go, factorised. A nice little method. Do go over it and make sure you understand it. It is quite useful. Now the other type of quadratic you've seen are the difference of two squares. So when you've got two square numbers and you're subtracting them, so remember your square numbers are 1, 2 2s are 4, 3 3s are 9, 4 4s are 16, 25, 36, 49, 64, 81, 100, and so on. So you've got to learn just get used to recognise your square numbers. So let's do our first example. We could have y squared minus 49. So it's recognised when you've only got two terms, you think, oh, I haven't got 3 terms, so it's not going to be 2 brackets. But you've got to spot the difference of two squares. So 2 square terms that are being subtracted because there's a special method. So y squared minus 49, I say, oh, 49 is a square number. It can be written as 7 squared, and I'm working out the difference of them. So it's dots. So you open 2 brackets, and you have your y and 7 in each bracket. You make one positive, the other negative, and there you go. We could have a squared minus 225. And of course you know that a squared minus 15 squared. Because 15 times 15, you might need to just double check. So 15 times 15 will give you 225. So you've got two square numbers, you're subtracting, we can put them into two brackets. So we can have a minus 15 in one bracket and a plus 15 in the other bracket. So it's the only time when you've got two terms in a quadratic expression where they will be factorised into two brackets. You've also got to look for ways that this might be disguised. So for example, you could have 4x squared minus you have 4x squared minus 64. So I could see, 4x squared. So 4 is a square number and x is squared. I can write that as 2x all squared minus 8 squared. So it's this you've got to look at. That means that in each bracket I'll have a 2x and an 8, a 2x and an 8. One will be positive and one will be negative. Okay. I suppose you might have also realised, I can take 4 out. I could write that as x squared minus 4 into 64 goes once and 16. And that would give you 4 x squared minus 4 squared, which is also 4 x minus 4 x plus 4. Okay, so simplify first if you can, and then factorise. We could have 5b squared minus 125. I could take out a factor of 5 and have b squared minus 25. And then you should say, I can simplify that still further, because b squared minus 5 squared. I've got a difference of 2 squares inside my bracket. So that means I can factorise this bracket as b minus 5, b plus 5. Okay. If I add on another, you could have 25x squared minus 1 over 9 y squared. Well, I can't factorise quite easily there, but I can see I've got two square numbers, as it were. I could write this as 5x all squared. 1/9 I could write as 1/3 y all squared. And then inside my bracket I'll have 5x minus y over 3, or 1/3 y. And in the other bracket 5x plus y over 3. So don't worry if there's fractions, just apply the same rules. And as I've said there, you try and remember 1/3 y is the same as y over 3. If you had 2/3 y, you could write it as 2y over 3. Just a nice little fact to remember for later on. 6.4a is these are where we're applying what we've learnt. So if we look at those questions in question 3, so if we look at question 3 on page 119, it's asked you to carry out these calculations without using a calculator. So if we look at B, it says 34 squared minus 26 squared. Now you can see that we've got two squared numbers and we're asked to work out the difference of them. So you think, I know that my dots, difference of two squares, so I know that x squared minus y squared can be written as x minus y, x plus y. So if I take this, I can say, okay, that's like saying 34 minus 26 and 34 plus 26. 34 minus 26 will give me 8. And 34 plus 26 is 30, 40, 50, 60. And you know 6 8s are 48, or 8 6s are 48. Add a 0, 480. So we can use these methods quite nicely to work out slightly more complicated expressions. The last thing I'm going to go through, so on this slide, is questions involving algebraic fractions. So I'm not going to ask everyone to do this, but I'm going to look at question 15b here. And we've been asked to simplify fully these expressions. And the b is 2y squared plus 17y minus 30 over y squared minus 100. Now, before we do anything, we're going to look at the numerator and the denominator separately, and we're going to try and factorize each. Okay, so we're going to factorize the numerator and the denominator. So I'm going to take 2y squared plus 17y minus 30. And using that method, the method that I've just shown you, I can say a equals 2, b equals 17, and c equals 30. So my AC should be minus 30 there. My AC is going to be minus 60, and b equals 17. So we're looking for two numbers with a product of minus 60 and a sum of 17. So I can have 20 and minus 3. Okay, so I can use those. So I'm going to take this expression, my 2y squared, and instead of the 17y, I can write plus 20y minus 3y, and then have my minus 30. We then factorise the first two pairs, so I have 2y, y plus 10 in one bracket, minus, factorise the second pair of numbers, I'll have 3y, bracket y plus 10. The brackets have got to be the same. We know that one's right, but also you've got to remember your signs, and minus 3 times plus 10 will give me minus 30. We then say the two numbers outside the bracket go in the first bracket, so 2y minus... Sorry, it's not a y outside there, is it? That's just a y. So we have 2y minus 3, and then the y plus 10 goes in the second bracket. So we've factorised the top part here. So the top part becomes that. Okay. We also need to factorise a denominator. So we have y squared minus 100. We can see is a difference of two squares. So y squared minus 10 squared. And that will give us y plus 10 in one bracket and y minus 10 in the other bracket. So now we can finish off the question. We can say, okay, 2y squared plus 17y minus 30 over y squared minus 100 can be written, using our factorised form, as 2y minus 3 times y plus 10, all divided by y plus 10 over y minus 10. And we can then look and see if we can simplify further. So I can cancel out the two brackets. Remember, we can only cancel out half brackets, not part of brackets. So our final answer is going to be, see if I can move this up a bit. Yeah, so our final answer is going to be 2y minus 3 over y minus 10. Now, this is just, these look harder than they are, but it's just putting together all the things that we've done in this lesson and previously on factorising quadratics. Now, I hope I've gone some way to explaining how to do things, and the important thing with factorising and quadratics is just lots of practice. So I will set some work on Insight and what I expect you to do. If you have any problems, you must talk to me through them. There will be a lesson on Tuesday as usual at the normal time. I would like as many of you there as possible. It is supposed to be compulsory. I do understand some of you have problems with computers and internet and whatever, but it is compulsory, it's not optional. So if you can get on, you must get on. And this topic is so important, and the more practice you get, the better that you get at it. So I will also see if I can find some extra sheets for you to do. We have done quite a lot in the past, so hopefully for most of you it will just be revision. But please go through this PowerPoint, stop it, go over it again, make sure you understand it, do some questions and ask me if you get stuck.